Steadfast, the power to move mountains. Steadfast is the new Class 60 diesel locomotive on which the continued success of rail freight will depend, both in the 1990s and the next century. It's the driving force, one of 100 brush-electric, 127-ton, 3,100 horsepower diesel locomotives with the capacity almost literally to move mountains. The mountains of coal, steel, petroleum products, construction materials and general freight, which will give rail freight a competitive edge. To describe Steadfast in simple, factual terms like that is of course accurate, but it doesn't take account of the years of careful thought and design that have gone into supplementing older engines with a new locomotive that's able to meet every challenge that the future has in store. And it also ignores the fact that over the next 2 years we'll be investing more than £120 million to make sure our drivers have the latest and best machine for the tasks ahead. Between them, the various subsectors of rail freight are the most profitable part of the whole BR operation. And because it's in all our interests, we intend to keep it that way. Our biggest competition comes from road haulage. Our customers know this and are quick to use our competitors' strengths by requiring that our contracts have penalty clauses triggered by late delivery or any breakdown in our service. They have their problems too and are constantly trying to improve the power and capacity of their vehicles. The new Class 60 is our response. It's a machine that they simply cannot match. Now this program will introduce you to the new locomotive and give you, the driver, the chance to see all the advantages that it has to offer. Because in the end, it's teamwork that delivers the goods. At all times and in all conditions, our competitive edge is in your hands. The new Class 60 was designed and is built with this in mind. From the initial concept to the finished machine, we've ensured that those who will drive the locomotive have been fully involved in its layout and design. Some of our most experienced drivers have worked alongside the designers and engineers to make certain that the theory and the practice come together to give the driver what's needed. Not on the drawing board, but on the train, late at night with a vital delivery in any conditions. An idle locomotive isn't good for business, and it's not good for morale. As this program unfolds, you'll see that Steadfast is the most accessible, most reliable, most user-friendly locomotive yet to come into service. You'll see that Class 60 has a unique system of fault identification to assist the driver in finding and rectifying breakdowns which may occur. There's nothing about the new locomotive that you'll find hard to understand. Every driver will benefit from a practical conversion course of which this video forms a part. It'll concentrate on the finding and rectification of common faults. And in it you'll see for yourselves how the latest technology has been applied where it's most important to help the driving force get on with the job. The basic layout of the Class 60 is much as one would expect. Seen from the left-hand side, side B, behind the number 1 end cab, is the radiator compartment. Behind this is the engine compartment, the clean air compartment, and then the number 2 end cab. Inside, the first pleasant surprise is the accessibility of all the key components and the space available to the driver. As is to be expected, some of the components are in slightly unfamiliar locations, and the first job of any driver converting to the Class 60 will be to satisfy themselves that they know where everything is. One piece of equipment which will, however, be completely unfamiliar is this, the diagnostic panel. This is the nerve centre of the Class 60, and one of the reasons why it's such a revolutionary locomotive. This is the display screen of the microprocessor, which identifies and records the exact nature of any fault. Coupled to sensors in almost every part of the locomotive, it can eliminate the need for time-consuming checks by spelling out exactly where the problem lies. It also saves wasted time by indicating that in some cases the problem may be beyond rectification by the driver. It gives on-board advice which even the most mechanically adept driver will soon learn to appreciate for what it is, the sensible application of new technology to the solution of practical problems. We'll now look at some of the more common faults and their rectification, and show how the computer helps the driver to find them and deal with them. Engine stopped. Now, if the indicator doesn't change to amber within 50 seconds of the engine start button being pressed, the problem may lie in a number of areas. The control cubicle power compartment door switches aren't in their correct position. Check both switches. If the voltage is too low, press the reset button and attempt to restart. After 3 attempts, the loco will be a failure. Look at the circuit breakers. It may be that A, the control circuit breakers, or B, the start circuit breakers 1 and 2, or C, the electronic circuit breakers have tripped. If they will not reset, the locomotive is a failure. If the fire extinguisher head is not in position, the engine will not start. Similarly, if the extinguisher switch has been left in the isolated position, the engine will not start. If the fire pressure switch is not reset after manual operation, the same applies. If the cutout switch is left in the off position, reset it to normal and try again. If after 3 attempts the engine fails to start, the starting motors may have overheated. Let them cool before trying again. If after running all the engine stops, there are 3 most likely reasons. Loss of oil pressure. Check level of oil using the screw-in dipstick, which features 2 types of scales. Check the diagnostic panel screen. If it indicates a fault in the electronics, for example a power supply fault, the locomotive is a failure. If, however, the micro-healthy light is out, check the electronic circuit breaker. Try to reset it. If it will not reset, then treat the locomotive as a failure. Whilst at the diagnostic panel, check to see if the water level low indicator is flashing. If so, check the gauge. If it is, the locomotive is also a failure. Power loss. If power is lost at all positions of the power handle, move straight to the diagnostic panel display. Having checked that the computer itself is functioning normally, look for the following indications. Engine water temperature high. If this indicator is flashing red, keep the engine running to maintain water circulation. If the rad fan fault is flashing, check the radiator fan breakers 1 and 2. If the water temperature indicator reverts to a steady red, then the water temperature has dropped and power may be restored. When the auxiliary field fault light is flashing, press the reset button. If the flashing doesn't stop and power isn't restored, the locomotive is a failure. If the diagnostic panel shows auxiliary earth fault, press the reset button. If the warning light reverts to a steady red and power is restored, it is safe to proceed. The ability of the diagnostic panel to pinpoint faults quickly and accurately is one of the great advantages of the Class 60 locomotive. In the case of general power loss, having first checked that the computer itself is working properly, any of the following indications will help the driver. If the main alternator temperature high indicator is flashing, wait until it shows a continuous light when the alternator will have cooled down and power may be regained. Exactly the same procedure applies in the case of the main rectifier over temperature light. If the engine maintenance switch is left in the maintenance position, power failure will result. It can only be restored when the switch is reset to the normal position. In the case of traction motor overload, return the power handle to the off position and make up to 3 attempts to regain power. If the fault persists, check the diagnostic panel. If it shows traction motor overload 1 to 6, turn the motor isolating switch to isolate the motor which is indicating overload, and then proceed at reduced power. Power earth fault. Return the power controller to off. If fault persists, try isolating traction motors. If a brake pipe fault is indicated, check the gauge. If pressure is shown at less than 5 bars when no braking has been applied, check for train and/or loco faults. Another check which should be made when brake pipe pressure has been lost is the AWS and the brake control circuit breakers. If so, reset. In the case of power loss, indicates a traction motor blower fault. If this indicator is flashing, check the motor blower circuit breakers. One of them has reset. The locomotive may proceed on reduced power, applied only. If this is the case with both circuit breakers, then the locomotive failure. Fast, effective identification of faults. Clean and comfortable working conditions. Class 60 is a locomotive designed for the job and designed with the driver in mind. The introduction of Steadfast will bring widespread benefits throughout the rail freight portfolio. To begin with, they'll be allocated to those areas where a fast, efficient, all-weather service is of the utmost priority and where perhaps the competition is toughest. With the power to haul a single-headed load of some 3,000 tons in almost any condition, Steadfast is the workhorse of the future. It would take 90 juggernauts to do this.